Alright guys, I'm putting in 2 practice problems from systems of equations with 3 by 3 systems, okay? And the first one that I'm going to put looks like this. X plus y plus z is equal to 0. The second one is negative 2x plus 2y minus 4z is equal to 12. And the last is 2x minus 3y minus z is equal to 7. Here we go. This is why you will struggle some during this process. Let me give you the caveat up front. The process that we use for this problem may or may not be different than the process for a different problem. Okay? Your processes for different problems depend on what you're given. Okay? So let me give you at least, if you're totally lost, where you should start. Okay? This is a 3 by 3 system. That means 3 equations with 3 variables. If you have all 3 variables on every single one, this one will work every single time. Okay, no worries. I think she's heard that I was calling her. Anyway, so if you have, I think I said system and she thought I said Siri. If you have 3 equations with 3 variables, this process will work every single time. Okay, here we go. My goal is through elimination to make this into a 2 by 2 system where there's 2 equations with 2 variables. And this process will work if I have all 3 variables in the first row, the second row, and the third row. Guys, this notation that I'm showing you today is what next class will be all about. And the sooner you get used to it, the easier it will be then. Alright, here we go. My goal is to get these 2. I'm going to eliminate a variable of my choosing, and I'm going to create an equation of what it would become from those 2. So guys, look at row 1 and look at row 2. Which variable looks like I can eliminate it fairly easily? X. So here we go. We're going to multiply. We're going to multiply row 1 with what? 2. Here we go. So write 2 times r sub 1. And what this means is, and guys, your work has to be neat, okay? Even though I'm giving this to you before you start, it has to be neat. Otherwise, it's hard to follow your stuff, okay? Even yourself, to follow your own stuff. 2 times row 1 means this. 2x plus 2y plus 2z is 0. That's what 2 times r1 looks like. Now, I'm going to add what to that? R2. I'm going to add row 2. Guys, did we change row 2? No. We didn't multiply it by a negative. We didn't multiply it by 2. It stayed the same. So I'm just going to write exactly how it looks like right now. Now, most important part. The notes that you saw yesterday, sometimes they subtracted these systems. And guys, that's where the mistakes start to happen. When you subtract negatives, that's where a lot of mistakes happen. So my suggestion to you is still add it the way you see it. Okay? So here we go. If I add 2x and negative 2x, what do they cancel to? They cancel to 0, right? So here we go. We have 4y, a positive 2 plus a negative 4, negative 2z. Let's say I put a positive 2z, because I mistakenly put a positive. Everything that you do after that is going to be wrong. So you have to be so very careful and precise with all of your work. Okay? And you would get 12. So this is my equation that I built from the first 2 rows by eliminating the variable x. Any questions? Yes?
Where did you get the first equation from? Like the 2x plus 2y?
The first equation here was because I did 2 times r1. Okay? No, that's a good question. You have to, because otherwise it's going to be a frustrating day today. Please ask me the questions now, okay? So 2 times r1 is that. Now, the second part is this. Grab the second and the third equation because we're going to build the other one. Okay? So guys, what could I do to row 2 and row 3? Nothing. I just add them up right now. So work-wise, I want you to do row sub 2 plus row sub 3 would equal the following. Nothing changed. I have a negative 2x plus 2y minus 4z is equal to 12. Then I'm going to add to a 2x minus 3y minus z is equal to 7. It's very important that we stay consistent. And yes, I'm going to add these together. Okay? Obviously, our x's cancel out. You tell me, guys, how many y's do you see? Negative 1. Negative 1. So negative y, how many z's do you see? Negative 5. And then what do I have on the far right? 19. Okay. My first step is done. I've created a 3 by 3 system and transformed it to a 2 by 2 system. Okay? Now from here, all I'm going to do is treat it like a totally new problem, like we did on the quiz last class, and just solve it out. I could use substitution, or I could use elimination. Okay? The big thing that I will tell you right now that you recognize is that you have the same variables. Sometimes you may not, and we're going to look at something in a minute where things will change. Alright, you tell me, guys, how could I solve this 2 by 2? What should I do? Yeah, multiply the bottom by 4. So here we go. Let's label these row, we could even label it row 4 and row 5, as long as we keep track of it. Okay? So the bottom one will be multiplied by 4. So we could say row 5 is multiplied by, you see what I'm doing? Row 5 is multiplied by 4, so that I get negative 4y minus 20z is equal to 76. Okay? What do I do to row 4? I'm just going to add it, but do I multiply it by anything? No. So it's just going to be plus row 4. So we would put 4y minus 2z, we get 12, and again, the most important thing so that we stay consistent is we're going to add these. What happened to my y's? They cancel, they're zeroing out. How many z's do I have? Negative 22, and then I have 88. 88, right? So 12 and 76. Anyone, what's my z value? Negative 4. So guys, if you're off by a negative, again, as soon as you make, and this was said all day, just a small error throws the whole problem off. Okay? Here we go. Watch my roadmap. We went from a 3 by 3 to a 2 by 2, solved a 2 by 2 in order to get my final answer for one of my variables. Okay? To use z now, I'm going to backtrack exactly the way I came from. You with me? So let's take z, which is negative 4, and let's put it in one of these two equations. Let's say we put it on the top one. So minus 2 times negative 4 is the same as adding 8, and we have 12. Can you tell me, do the algebra real quick? What would I do? Subtract 8 and divide by 4, so y is 1. Now I have 2 of the 3 answers. Now I'm going to keep going back. Now both of these are going to go with me, and I'm going to use one of these 3 equations to solve for x. Okay? Let's say I use the first one. If I use the first equation, I would write x plus y, which was 1, plus z, which is negative 4, is equal to 0. You with me? What would x equal? 3. Now look, red alert, red alert. I'm about to say something very important. In your answer, I want you to put it like x, comma, y, comma, z, comma. So you would put 3, 1, negative 4, just like this, into that little computer program that I'm going to open up for you in just a bit. Please don't put spaces after commas. Now, let's see if you're already thinking about this. Let's see how many good notes were taken last night. Let's say you put this into that program and it says that it's not the right answer. What should your answer be? It's saying that this one's not the right answer, but we did everything correct. Not no solution, but infinite solutions. Infinite solutions means there's other answers out there. This is just one of them. You see what I'm saying? So if it gives you an error and says you're not right, it means because there's infinite solutions. You with me? That's if you did your math completely correct. Are we good? Okay. Alright, so now, let me do another example real quick. Put that off to the side. Here comes the other one because this is different. And this one's going to be a different case scenario basis. Okay? And here's the thing. I'm trying to help you with as much experience as I can as far as with these problems so that you don't have to do 200 or whatever to understand what's going on. Here we go. So write this one down. It's 2x plus y is equal to 9. And I have two other ones. I have x minus 2z is equal to negative 3. And I have 2y plus 3z is equal to 15. All right. Will this process that I did last time work like that? No. Why? Because I don't have all of the variables on all of them. So my strategy has to change some. You with me? Now, I heard it. Substitution could work. Okay? And if you substituted, I think people who want to substitute would probably grab maybe this one and put negative 3 plus 2z, and they would probably substitute that somewhere here. You with me? So if they did, they have 2 times negative 3 plus 2z, and then plus y is equal to 9. Can you tell me what variables do they have now? They don't have all of them. They have z, and they have y. You with me? Do I have to do substitution with this to bring from my other one? I don't. Because this one's different. My goal is ultimately to get a 2x2 system with 2 variables. This substitution allowed me to get it down to z and y. And look, very conveniently for us, this one already is in z and y. You with me? So all I have to do is bring this over here, and that's different. That's different than what we did last problem. If I simplify this out, I'd get a negative 6 plus 4z plus y is equal to 9, which of course if I add the 6 over would change this to a 15. So I have a positive 4z plus y is equal to 15. All I did was manipulate and distribute this one right here. You with me? So now the second equation is still 2y plus 3z is equal to 15. This was my goal. My goal, although this one was different the way we got there, was to get 2 equations with 2 variables. Okay? And yeah, I would probably line them up where the y's were right on top of each other and where the z's were right on top of each other. Just be careful when you do it, that you don't change something sign that you shouldn't. And now from here, I can do the elimination method. What would I do, guys, from here? Multiply the top by a negative 2. And just keep going from there. Do we see the difference from the 2 problems that we just did? Okay. You're going to struggle but I want you to stay positive. I want you to stay smiling. I want you to keep working hard. You have 12 questions. You can divide and conquer, or you can have two people doing the same question together, which I think you should probably do to check each other's work. But ultimately, between your entire team, I need to see how many of the 12 that you got complete at the end of the period, okay? You get 100 points for each, and if you get all, I will double your score. Are there any questions? Okay, one more thing. XYZ is an answer, okay? The numbers, right? Your other answers will be this. No solution or infinite solutions. Oops. With an S. Those are the only 3 types of answers that you got. We good? All right, let's do it.